Okay, welcome back, dear students. What we are going for is the last section of this chapter. It is known as cyclic quadrilateral. So let us see what it is. See, I am considering a point. Okay, you can see a point A. I am drawing a circle, right? Now, I am taking, can you see this one? A circle with the center at A.
Yes, sir.
Now I am considering a point B on the circle, another point C on the circle. See the circle, it is getting D on the circle and E on the circle. So I took 4 points B, C, D, E on the circle. See that all the 4 points are on the circle. Okay, not in the interior of the circle, not in the exterior of the circle, but the 4 points are taken on the circle, right? On this. Now see what I am doing is I am connecting B and C. I am connecting C and D. I connect D and E. I connect E and B. Which type of figure is inscribed in the circle? Circle के अंदर कौन सा figure मिलेगा आपको?
Quadrilateral.
Very good, Prabha. It is a quadrilateral. It is a quadrilateral. Now you see, I can move this. Okay, I can move this. I can vary the shape of this quadrilateral. See, I can move all the 4 points. I made it in such a way that animation is possible on this quadrilateral. See, I can shape the quadrilateral in any. See. Now, what is the importance of this quadrilateral? We know a quadrilateral have 4 vertices. What about the 4 vertices? All the 4 vertices are
On the circle.
on the circle or on the circle. Such a quadrilateral is known as a
cyclic.
It is known as a cyclic quadrilateral. So by a normal quadrilateral we mean it is a closed figure having 4 sides, but by a cyclic quadrilateral we mean a quadrilateral whose all the 4 vertices are on the circle. Exactly, it should fit on the circle, right? Now, अभी हम एक एंगल, इसका एक मेन प्रॉपर्टी है ना, मैं बोलने से पहले दिखाता हूँ बात. See, एक एंगल में क्रिएट किया उधर, you can see alpha angle CBE equal to 93.94. ये एंगल देखो कौन सा एंगल है वो?
एंगल CDE.
एंगल CDE. अभी मैं दो रेड कलर में 2 एंगल दिखाया हूँ इधर. Both angles are which type of angles for the quadrilateral? They are adjacent.
Supplementary angles.
Are they adjacent angles? ये quadrilateral के एक दूसरे से दिखता है ना, इधर से उधर दिखता है. Such angles we are known as they are opposite angles. They are yes sir. Opposite angles of the quadrilateral. तो ये दोनों opposite angle दिखाया हमने, है ना? Opposite angles are shown here. Now you see. Let us see what are the sum of opposite angles. What are the sum of
180 degree.
Let us see. So the angles are alpha and gamma, है ना? See what is the angle of alpha? 93.94. इधर आ रहा है ना? 93.94. Gamma 86.06. When you add, you can see that it is 180. Now when it stands, देखो मैं अभी change कर रहा हूँ, okay? I am making the animation here. See, changing, but the total is stable at अभी दोनों 90 मिला था, एक्सीडेंटली मिला था, ऐसा मिलते नहीं ज्यादातर. Can you see the change?
Yes, sir.
But what is the property? Even when the opposite angles are changing, total is always
180 degree.
180 degree. Now I made it both as 90 plus 90, but in any way you change, total is always
180 degree.
180 degree. That is what Sridhar said initially. If the sum of 2 angles is 180 degree, such angles were known as
Supplementary angles.
Supplementary angles.
Supplementary angles.
Very nice. Therefore, the very important property of cyclic quadrilateral is that opposite angles are always supplementary. That means sum of opposite angles is always 180 degree. So here I consider only one pair of opposite angles. Let us see what happened to the other pair. It is very easy to assess because total angle in any quadrilateral is always 360 degree, right? Total angle is always 360 degree. Therefore, if sum of these two angles is 180, definitely sum of the other two should be 180. Still, let us see. So, I mark this angle. You can see a new angle formed beta equal to 77.12 degree, the another opposite angle. So, opposite pairs are shown in same color. Okay, alpha and gamma in red color, beta and delta in green color. Now, you see. So we are going to calculate beta plus delta. See beta plus delta, here it is. Okay. Now let us see whether they change according to a change in angle. See, are they changing?
Yes, sir.
They are changing. But what about the total?
It is always same 180 degree.
Always 180 degree. That means total always stand. Sum of opposite angles in any cyclic quadrilateral is always 180 degree. So this is what the property we are going to use in solving the upcoming problems. Okay. So once again, first we define a cyclic quadrilateral. What we mean by a cyclic quadrilateral? What is the meaning of cyclic quadrilateral?
Which quadrilateral lies in the circle? It is called the cyclic quadrilateral.
A cyclic quadrilateral whose all the four vertices are on the circle. वैसा ही बोल रहे हैं all the चारों vertices circle के ऊपर ही होना चाहिए, अंदर होने से नहीं चलेगा क्योंकि ये मैं थोड़ा अंदर खींचा ना. So तीन vertices may be on the circle and fourth may be inside. So inside बोलना it's not perfect. What we have to say is a quadrilateral whose all the four vertices are on the circle is known as a cyclic quadrilateral. The very important property of cyclic quadrilateral is that total sum
of opposite angles
sum
is
of
always
opposite angles supplementary is 180 degree or opposite angles of a cyclic quadrilateral is. So here it is. Very good morning, dear students. What we are proving is the most important theorem in the chapter circles. Prove that the angle subtended by an arc at the center of the circle is double the angle subtended by at the remaining part of the arc. See the figure. In a circle, you consider an arc AB. Join the end points of arc AB with the center O. Then consider any point C on remaining part of the arc, of course in the major arc. Then connect A and B with C. To prove the theorem, for the sake of proving theorem, draw a line from C through the center O to D. Then you can see that there forms two triangles OAC and OBC. Consider each triangle. First we are considering triangle OAC. So that triangle is drawn there. Triangle OAC is drawn there. Out of that or in that angle AOD is the exterior angle. So in this theorem we can apply exterior angle theorem. So by exterior angle theorem, exterior angle is equal to sum of opposite interior angles. Therefore, angle AOD is equal to angle OAC plus angle OCA. But OA and OC are radii of the circle. Now we had the theorem, in a triangle, if two sides are equal, opposite angles are equal. Therefore, angle OAC equal to angle OCA. That can be written as angle OCA plus angle OCA. So we are getting 2 times angle OCA. Very similar way, consider the next triangle OBC. Again applying exterior angle theorem. The exterior angle BOD equal to opposite interior angles OBC plus angle OCB. Once again, OB and OC are radii of the circle. Therefore, angle BOD is equal to angle OCB plus angle OCB for 2 times angle OCB. So we are representing them as two equations, equation 1 and equation 2. Finally, to prove our result, we have to add equation 1 and equation 2. Adding 1 and 2, see what we are getting is angle AOD plus angle BOD equal to 2 times angle OCA plus 2 times angle OCB. Left side AOD plus BOD. See the figure, AOD plus BOD gives the total angle at the center of the circle, angle AOB. So the left side reduces to angle AOB is equal to 2 times 2 is taken as common factor. See the figure again, angle OCA plus angle OCB gives the total angle at the remaining part of the arc, angle ACB. Therefore, we reached at the final line, angle AOB is equal to 2 times angle ACB. That means angle at the center by an arc is equal to double the angle made by its remaining part of the